Welcome to OpenBox Education. If you like this video, please subscribe to my channel and share to your friends.
Hello everyone. In this video, I am going to explain about series voltage regulator and shunt voltage regulator. In a regulator, we have a control element. So that control element is connected to that load resistance RL. So if the control element is connected in series to that load resistance RL, then we can call it as a series voltage regulator. That is, at the input we will get that V in, and across the load resistance RL we will get that V out. So this control element is connected in series to the load resistance RL, then we can call it as a series voltage regulator. And coming to that shunt voltage regulator, here we have the load resistance RL and the control element, if it is connected in parallel, or we can call it as a shunt to the load resistance RL, then we can call it as a shunt voltage regulator. Means here we have the V in, and across the load resistance RL we will get that as V out. So this is the difference between how we are differentiating the series voltage regulator and shunt voltage regulator. This is the first point. Now coming to this series voltage regulator, as we know that for a series voltage regulator, the control element is connected in series to the load resistance RL. We can call it as a series voltage regulator. So coming to this general example, here I am taking that water tap. This is the water controller, and here we will give that water in, and here we will get that water out. Okay, so for example, water in is 100 and the water out is also 100. Now water in is increased to 120, then the water output also should increase it to 120, but we have to maintain that water out as 100 only. That is what we are calling regulating water flow. So to maintain that water flow 100 only, we have to use this water controller, nothing but this is we'll call tap. So by using this tap, we are going to maintain the output as 100 only. Even the water in is increasing, we should maintain constant water output. That is what we will call regulating of water flow. Now coming to this series voltage regulator block diagram. This is the control element we have, and this is the V in, and this is the V out. So for example, V in is 100 volts and V out, which is connected to the load resistance RL, and V out always we have to maintain as 100 volts for example. Okay, so if the input voltage is increased to 120 volts, then the output of this series voltage regulator you have to maintain as 100 volts only. But what happened? The input voltage is increased to 120 volts. Then output voltage is also increased to 120 volts. Then how this will be regulated? To maintain as 100 volts. So here we have the sample circuit is there. The sample circuit always take the sample of the output voltage. What is the sample of the output voltage now? It is 120 volts. Okay, and here this is the reference voltage. The reference voltage always maintained as input voltage. It will be constant. That reference voltage is 100 volts, same as input voltage. Okay, now what happened? The sample circuit output is connected to the comparator circuit, and this reference voltage is also connected to comparator circuit. So what it will do? It will make the difference, that is 120 minus 100 volts. Then you will get that difference voltage as 20 volts. Then based on this 20 volts, the control element will controls the output voltage. That is, now output voltage is 120 because of input voltage is 120. So what it will do? Here we got the difference voltage 20 volts. Already we know that the input voltage is increased to 120. Now we have to maintain that output voltage as 100 volts only. Okay, so we have to maintain that output as 100 volts only. Then what it will do now, control element, it will reduce the input voltage to 20 volts. That is, here 120, it will make it as minus 20 here. Then at the output you will get as 100 volts. So this is how that series voltage regulator maintains that output voltage as constant. Now coming to the shunt voltage regulator, the control element is connected parallel to the load. Then we will call it as a shunt voltage regulator. I'm not going everything with the block diagram, just I will explain here. So this is the In, and at the V out we will get that I out also. Okay, what happened? For example, if input current is increased, if the input current is increased, automatically the output current is also increased. To maintain the output current constant, okay, to maintain the output current constant, what happened? The increased current will flow through this control element. That's it. For example, In is 10 amperes, for example, and I out is also 10 amperes. If the In is increased to 15 amperes, then what happened? You have to maintain the output current as 10 amperes only at the output. Then increased 5 amperes will flow through the control element. That is how this output voltage maintained as constant in shunt voltage regulator. Go through the block diagram, you will understand very easily. This is how shunt voltage regulator will works. That is, the increased current will flow through the control element. That's it. It will be grounded simply. So then what happened? The output current will be maintained as constant. If the output current is constant, then output voltage is also constant. That is how the shunt voltage regulator will work. Thank you so much. If you like this video, please subscribe to my channel.